Okay, once again, thank you all for joining. We are beginning with today's session, this quick webinar. We're going to talk about how to streamline your concrete design with large structures. So another way of looking at this is how to bring a 3D model of your structure, prepare that 3D model, and then utilize the multi-story designer to leverage the S concrete design engine. Okay, so well, once again, thank you all for joining. Thank you all for your time. My name is Tatiana Aguilar. I am an application engineer at Altair, focusing on the AEC, architecture, engineering, and construction set of tools. So here it's a quick look of today's agenda. We're going to talk really quickly about the concrete design with S-frame, something that many of you already know, the S-concrete set of tools. Then we're going to go about the S-frame model setup. This workflow is taken from an S-frame model, which is our finite element analysis tool, but also consider that this applies to other type of 3D modeling files that you may have. After that, we're going to jump into the Multistory Designer tool that will allows us to execute a preliminary concrete design setup and obtain some results. Then we're going to go through the design group environment and the SCO or S concrete file generation and batch processing. After that, we're going to go in detail how to create different engineering design reports and the different types of reports that we can create. And then we're going to go into a quick Q&A session. All right. So let's go ahead with it. And this slide is just set here to illustrate the different interoperability within our tools and third-party software and third-party tools. So whether you have your 3D model in a third-party model such as Autodesk, ETABS models, you can bring these into S-frame or directly, in the case of ETABS, directly into the Multistory Designer, and you can export these results into the design workflow. Okay, so our design and workflow philosophy is to execute your structural analysis and then take those results into your concrete design. Okay, in this case, concrete. So we're just going to have a little bit of introduction to what is the concrete design using S-frame tools. Okay, we have three different approaches to what is the concrete section design in S-frame. Remember that S-frame is our finite element analysis tool where you already have some kind of model. So when we have these models, we're going to have our elements. And in these elements, after obtaining results for our analysis, we can just right click on the element and then click on the concrete design interface. This will take us into the concrete design modules within S-frame. Okay, that is one way to do it. The second one is through the integrated concrete design. Okay, so once that we have selected member, we can edit directly the section of a particular members and use the S concrete integrated design visualization, right? We have all of the availability of S concrete's design engine within S-frame's modeling. Okay, this is exclusive to the S-Frame environment. You have your model, you click on the panel, sorry, on the section that you want to edit, and you can go through your concrete design checks. And the last one, and the one that we are going to talk about today, it's the S-Concrete Multistory Designer. This tool allows you to import the analysis data from your model, not only S-Frame, but also ETABS, and specify the reinforcement and execute all of the different design checks that are needed, as well as obtaining the report results for this. It's great for having very large structures with multi-stories, with multiple storage, with a large number of sections and groups, etc. Okay, so this is what we're going to be talking about today, later. So, what is the multi-story designer, and what is the general workflow of this? How to obtain the result? So we basically have 5 different and easy important steps. The first is to import the analysis data. This is after you already have your model ready. Then you specify the initial reinforcement by section type, and then you go to refine this reinforcement after getting these preliminary design checks. If you're happy with it, if you are convinced that you are getting preliminary design checks that are okay, you can generate the S-concrete files for each one of your elements in this model. It's going to automatically perform the batch code checks of all of the different sections. Then it generates the detailed design reports. So over here, it's a more illustrated workflow of what I just said. So you basically have your model, you analyze it, you have those data, you have that data, then you bring it into the multi-story designer, you set up your preliminary design code checks, you create the S-concrete files, and then you can open each one of those files for review and generating reports. If you are not happy or you want to review these designs, it's available to you to just at any time go back and re-execute and reassign your design parameters. Okay, so that is the general idea. But before we go into the multi-story designer, we need to set up our model. In this case, it's an S-frame model. So what we need to do is basically to have our model, our geometry, and these are the 4 important steps that we need to have before working with a multi-story design. First is having different sections assigned, concrete sections, having wall integration lines or piers, having different story identifiers. All right, all of this data is important. And then this is an important, very important step. It's to export this data to a Microsoft database file. In this Microsoft database file, we need to pay attention to include all the member forces, the wall and the pier forces, as well as all of the input data for these to work. Okay, so what's the first thing that we need to do? I'm going to open here our S-frame file. Okay, so what we have here is basically this structure with 10 different stories over here. And I'm going to render this so you can take a look at the different floors that we have. We have a concrete core and we have some bracing, some columns over here. Important, we can take a look, or we have to take a look at the section's properties that we have. Okay, so we have here the concrete columns here in blue, and then we have the concrete bracings over here. All right, this is important because this is what we are going to be checking against. All right, we also need to check on the material properties. As you can see, all of these, I'm going to just turn off that rendering. All of these elements over here are concrete concrete elements. This is a concrete with a 35 MPa. We can always take a look at these values. Okay. One other important thing is that your section properties they have to be compliant with what we call the S concrete sections, which basically translates to regular sections that can be beams, columns, or walls with T, L, rectangular, or columns. Sections that are within S Concrete's database, because the Multistory designer is going to run on S Concrete's engine design. So we need to keep this in mind. We can, of course, add as many different sections as we want, but for the case of this model, that's the way that we want to go, to keep it simple. Okay, so after we have set up our model correctly, we know that it's done. It's important to run an analysis, so we have all of the data inputs that we are going to need. So for this case, we run it. We have 12 different load cases. We don't have any messages on the solver. And after we do that, and we know that we can take a look at the results if we want to, just to make sure that we are looking into something that is adequate to what we want to design. Okay, so we have here our reactions, and we have our axial forces, our moments, and our shears. We even have our shell contours for our concrete shell, right? So we can take a look at all of our different results, but that isn't something that we're going to be diving into today. We are assuming that our results of the analysis are as expected, right? So after we've done that, and we're happy with it, we can go back into our geometry window over here, and then go to File and Export. Here we have different formats that we can export to, such as the DXF, SCI, BRML, the OptiStruct format. But the one that we want to work today with is the Access MDB, Access database. Now it's going to ask us, where do I want to save it? And this is where I'm going to click on Save. I want to replace this. It's okay. Then I'm going to be shown with this dialog over here, where it's important that we select everything that we want our Microsoft database to be included with. Very important. We need to select our full structure. We could create a file with certain members only or certain sections only, but for the sake of what we want to achieve with the multi-story designer, we need to go with the full structure. Then we also need to include all of the input data. This is important because it's going to create all of the database, a large database. Then we can select if we want to import all the load combinations or the load cases, or just a set of those either. In this file, I don't have load combinations. I only have load cases, so I could do this one as I want. And then when it comes to the results, it's important that we export all of the forces, okay? All of the forces that are going to be acting into our concrete sections. So member forces, wall forces and story and peer forces as well, if we have any peers, right? We can select all of the others, but it's going to create a much more or larger database, and it could take a bit more time to do this. So after all of that is selected, we can click on OK, and now it's creating the geometry, the loads, and the databases. Now, here is where the two different exports converge, okay? So for this workflow, what we are doing is that we are taking an S-frame file and exporting this. But if you have other type of files like an ETABS file, you can create a Microsoft database with all of this information. Okay, so after that has created it, we can see here that the Access database is created with all of this information. The floor data, the frame assignments, we have all of this information with the concrete sections, the design tag, each of the different labels, the stories that they belong to, and all of the other information we have over here: the joints, the load cases, the material property, the panel elements, the story definitions. Over here we have all of this important information, wall physical to analytical data, etc. So as long as you can create a Microsoft database file that contains all of this information, you can go on with the next part of the workflow, which is executing the multi-story designer, right? So I'm going to close this one as well as this one, and then I'm going to jump into my S Concrete application. For here, I have the S Concrete interface, the same that you already know, where you can create your needs, your columns, your walls, and make your checks, etc. We need to go through this one because, like I said, the multi-story designer runs on this S Concrete, on the S Concrete design engine. Okay. So the next thing that we are going to do is here. We're going to go here to run, and we have these different options: design constraints, automated design, batch processing, and at the very bottom we have the S-Concrete multi-story designer. So I click here, and the S-Concrete multi-story designer import options dialog shows up. Okay, here I have first to select my input path, where I stored my recently created file. Okay, you can see here that it's the file that I just created, 11, 20, 25 at this time. Okay, so you click here on open, and it automatically it's going to recognize the different items included in the MDB file. You can import the columns, the beams, the braces, and the piers if you have any. And you can set different filter options for all the recognized members. So here it's recognizing that we have different columns, beams, and braces. You can select if you want to import all of these or only some of these. When it comes to the piers as well, it's recognizing that we have 20 different pier types and different walls. And you can also select which load combinations under which type of load combination you can go to. All right. So after you do that, you can select what do you want to do. You also have options to import these as the walls designed as columns. And because we have pier shapes, we can click here on the pier shapes, and this option allows you to identify the different piers, shapes of the sections that are referred to, and how as the multi-story designer is interpreting this information. Okay, you can play around with the tolerances of the dimensions and the angles, and you can even deep manage this S-frame tier groups. Okay, so you have a lot of options for customization. And like I mentioned, this is important that we have the S concrete types of sections into our model, okay? Because this is where it's going to tell us, okay, this is the way that I am interpreting these sections. So if there is any mismatch between that, here is where you will see it, okay? After we have set up what we want to import and what not, we can click here on next. And what it's doing is that it's importing all of the selected elements from the S-frame model. So in this next step, we can specify the initial reinforcement by section type. Okay. This is a slide is just what I was explaining. Okay, so let's go back just to have a cleaner outlook over here. Okay, so in here we can select our preliminary standards. Okay, we have the options for our columns, our beams, and our walls. We can select the design code that we want to work with, ACIs, CSA, Euro codes, Indian codes, and even Korean codes are supported. Then we can also select the different types of bar types. For example, if I want to switch here to CSI and switch my bar type to Canadian, that is very easy to do. And then I can set my minimum vertical bar diameter to 25 instead of 20, as well as my tie bar. And I can do the same with the rest of the beams. For example, of course, when you have different recognized members, this is going to be different. For example, if you have beams, otherwise to the columns and the walls, you have options to the seismic parameters, right? You can apply minimum moments or include the slenderness, select the shear method. So all of this information, it's something that you can also select and leverage from the S Concrete design engine. So we click here and apply design standards to all the sections. And what it's doing is that it's applying all of those standards to the different members that we have done, right? So it has created and applied all of those standards, and it's executing a preliminary design code check, right? If I click here on the preliminary capacity results, I have my DCR, my capacity results onto each one of our section groups. Okay, I can do this for both my columns, my beams, and my walls. For example, in my walls, I know that I have a lot of different data, and here it's very useful to include all of the different stories that I have for my walls, for my beams, and for my columns, right? I can create all of these for the different stories and the selected stories as well. And if I want to take a deeper look at each one of these column forms, I can click here, and this is what it's the most similar interface to the S Concrete's interface. This design group is what we have here, and we can select and we can set the different reinforcement types, change the diameter, change the bar types, even change to a different layout configuration of the rebar. Okay, from here we have these two different options. We can, once that we have selected what we want in our preliminary checks, we can run either a code check from here and obtain the different checks that we would get from an S Concrete run. Okay, and we're getting for this selection group that the status is unacceptable, and we have the messages. Now, if you prefer to have a full S Concrete session for this type of section, you can click here on Run as Concrete, and it's going to automatically take you into the S Concrete interface that you know with that particular section. Now, please remember that if you want to have, if you want to make any edits over here, it's not going to be automatically saved. So you need to re-import it over here. All right. So you need to reapply it, and you can do that with each one of these files. Okay. If you make any changes over here, for example, if I change my raw vertical steel from 1 to 1.1, and then I click here on update, you can see how the DCRs have been updated as well. Okay, so after we're happy with this part, we can click here on next, and then we have the option to create our S-concrete files. Okay, this allows us to include our selection. We can set, for example, to preserve the columns or the beams or the walls. This is up to us. And then once that we have selected those, we can reselect the ones that we want to create our S-concrete files to, as well as our load combination. Okay, so what we all that we have left to do now is to create the S-concrete files of each one of these sections and section groups. So I click here, S-concrete files, and right now it's generating a different folder for each one of my sections. So you see here that I have the walls, I have the beams, and I have the columns. So I can open any of these files that is on this concrete file, and I will have this column over here, or this wall over here. Sorry, this wall over here, and I can check each one of those files individually. So we have brought all that model to the S-concrete interface. Okay, so let me just minimize this over here, and that is shown because I had this one ticked. Right now, I have my files created, but I still need to run a code check on each one of those. So I can execute a batch code check, and I can click here on Run as Concrete Batch. And what it's doing is that it has taken all of those files that we have created for the SCO, and it's code checking all of those concrete files. Now, of course, this running time is going to be different on the depending how complex, how large the file is. Okay, but in the case of this one, because we have a 10 story with many different sections, it's taking just a couple of seconds. Okay, you can also select over here the Run Auto Design. So if you are familiar with S-Concrete, you will know that it has a feature that allows you to execute automatically a design on each one of your sections by selecting your minimum and your maximum parameters. Okay, so you can also do that. After the concrete batch run has completed, it tells you that the time elapsed in this one 1 minute and 10 seconds. After that, you can click here on View Code, check results, and you have a couple different ways of seeing the code check results. This is the table results, where you have a summary of all the different sections. For example, we have here the walls, we have here the beams, we have only one set of beams, and we have the different types of walls, sorry, of columns. In here, you have the section type, you have the general information, you have your reinforcements information, and of course you also have your different messages. Okay, you have your warnings, and if it's acceptable or unacceptable, you have all of that information directly here. You can always export this data into a CSV file, so you can share it very easily through an Excel spreadsheet. Okay, so that is one option to go with your reports. But you have other options. If you click over here in create report, yes, I know. Here, if you go to create report, you have options to create two different types of reports. One is the PDF, and another one is the HTML. So you can always select what do you want to add. For example, I'm going to remove the walls right now. I'm just going to stay with the columns and the beams to create a PDF report. I click here on create report, and I have my S-Concrete code check results for this file. And here I have a quick summary of my columns, my beams, and if I were to have my walls, I would have them as well. This is a PDF, so you can import it, you can export it, you can share this widely. And I also have the schedule options for the sections. This is going to be executed on a story by story basis. Okay, so I can click, I need to select my file name. I click here on create report, and for this one, because I need to have the stories by stories, I need to go along with my walls. Okay, this is what has the information regarding on the story. So I click here one more time on create reports, and this is what I would have regarding the reports, right? Additionally, I can create HTML files just to visualize on the web. So that is one way of creating different design reports. Let me just go quickly through all of these because this is what we have already done, what we have explained about the reports after generating the files, running these on batch, and getting this final documentation. So what is the takeaway from this? The multi-story designer allows you to efficientize your workflow for designing concrete elements. So you can have large structures and very quickly code check and validate the design of that. It has a very powerful group management, so you can always put together different groups of columns or walls or story by story information. It uses the familiar S-Concrete design engine. So this is technology that has been in the market for a long time. So if you're already using S-Concrete, it's a great way to tackle and take your concrete design into the next level. Also, the design reports that are very useful and for what S-Concrete is widely known and loved are available at full capacity with the multi-story designer. And lastly, is that if you're already working with the Altair set of tools, especially the Advanced Structural Engineer suite, it's available to you. So you don't need to make any extra purchases or anything. You can just go into S-Concrete and start leveraging this technology, right? So this clears what we have today. This was a very quick question, only to show you how to leverage this technology really quickly. But if you have any questions or if you want to learn more, don't hesitate to reach out. We have a lot more of information on this particular topic, on how to execute group designs, how to leverage the different preliminary parameters, how to change, how etc. So I'm just going to open really quickly the floor for questions. So any questions?